Leon Andrews. And I know I keep saying these are great titles. I don't know who comes up with these titles, but Leon, if you're the one that came up with your title, it's another great one. The Swiss cheese model of layered API security, which is a mouthful, but it says a lot.
It does, and I can't claim the credit for coming up with that, I'm afraid, but I do have a shout out to the person who did, right at the start of this talk.
Right, it's awesome, and I'll hand it over to you. But I think Leon, you also win the where in the world you're joining us from today, because you are coming to us all the way from Sydney, right, Australia?
Yeah, so it's a nice chilly 9 degrees C here in Sydney at the moment, 6:30 in the morning. This is the first time I've actually opened my mouth and said any words this morning, so please forgive me if I'm sounding a little bit hoarse.
You sound great, and thank you so much for agreeing to jump on this early in your day. I'm going to hand it off to you, and I can't wait to listen to this last session.
Thank you. Thanks, everyone. So thank you. My name is Leon Andrews. So yeah, I'm down here in Sydney. So I hope everyone's been enjoying the sessions up until today. I'm obviously haven't really been able to participate, it having been the middle of the night, but I'm really looking forward to catching up on everything that I've missed. So I hope from this session you're going to leave with a bit of a different lens on how to think about API security. I'm going to try and resist making too many cheese-related puns, although maybe our moderation team might be able to think of something in the meantime. So a little bit about me. As you can see, I've been doing this stuff for quite a while now. My main focus these days is really on API management, mostly agnostically, but I do a fair bit of work with Apigee as well. And this is a little bit about Terem. So while that's up on the screen, I'll give you the sort of preamble a little bit about the talk. So this title and this sort of topic came up from a discussion with one of the senior engineers here at Terem, Marty Rowe. And Marty's actually ex-Air Force, the Royal Australian Air Force, to give it its full title. And being ex-Air Force, Marty's got some really interesting knowledge about aviation security, obviously, and lots of other sort of security as well. He introduced me to this idea of the Swiss cheese model, and how it could be applied to IT security and API security. It's something that's been quite big in the sort of risk management community for a while. And we thought, yeah, it's actually really, really applicable to thinking about API security. So I just want to give a shout out to Marty for the inspiration for that and for helping me put these slides together. So let's get into it. So the Swiss cheese model as a piece of cheese, and what you can't see yet, but in the model, this is how it's going to work. So the model depicts a system as a stack of slices of Swiss cheese, and we'll see that in a sec. Developed by a guy called James Reason, which is just such an awesome name for a psychologist. But this is the main sort of tenet of the whole thing. The holes in the cheese represent weaknesses in the barriers, so things that can get through your security layers. The holes are sort of randomly distributed, as they should be in a piece of Swiss cheese. But when you line up the cheese, when the holes in the slices align, that means a hazard can pass through. So as we all know, there should be more cheese than holes. But when it all gets sliced up and shuffled about, you really don't know how the holes are going to line up. And here's just a sort of selection of screenshots of people using the Swiss cheese model. Interestingly, most of these, the holes do line up. And there's an arrow that's kind of showing you a pathway to failure. So obviously the idea is that it's not possible to get all the way through. And here's the one that Wikipedia uses, their hero image. And if you just take a quick look at this one, it'll give you an idea of how we're going to start thinking about using this model for APIs. So I think this one gets the message across pretty well. Each layer does have some holes. Some of the layers in this picture as well are sort of a little bit broken, which is a good analogy too. But you need multiple layers to improve your success of blocking threats. And as we know in the case of COVID, sometimes the holes do line up, and especially if some of the slices are removed, and we've all experienced what happens there. So our layers of Swiss cheese for API management need to cover quite a lot of things. I mean, mostly we're obviously protecting against bad actors with specific intent, but there's a lot of other things we need to deal with as well. And this is where this model sort of starts to highlight the different sort of factors you need to take into consideration with API security. So we're looking at, we're dealing with a lot of human traits, just different levels of human skill level and intelligence, their motivation or energy to either attack or defend, their level of boredom or interest in the topic, and really their sort of appetite for risk or their appreciation of the risk. And maybe that sort of human propensity to just take risks. Humans make mistakes, they rush. We know that we're using software that isn't perfect, and there's sometimes exploitable bugs in them. And of course, a lot of those classic unknowns that need to be dealt with. But there are also a lot of knowns. Now, I won't go through the whole sort of OWASP 10 because you're probably all familiar with it, but the key thing here is that we can't focus on the API as being the single place where any weakness will lie. So this notion of there being an API. The truth is that these risks kind of manifest themselves differently and affect different parts of the stack. So if we start putting this into practice and start thinking about our layers, and in this Swiss cheese model for API security, I've come up with 11 layers, and I put a bonus layer on the end, actually. But also we're going to use two types of cheese. And for the technology layers, I'm thinking this is probably your prime king of Swiss cheese is your Emmental. But for these human layers, this sort of the human condition, if you like, maybe we've got a sort of cheaper and less reliable type of cheese. Your cheap sort of burger cheese, you can choose your own. And we're going to have multiple slices, remember, each layer performing a different thing. So with those two types of cheese, let's just go through the layers one by one, and I'll tell you what I think those layers look like. And as you might have guessed, we'll start with the network layer. So obviously this is your basic ring fence, your outer layer of security. But as we might start to see later, this layer can sometimes be relied upon a little bit too much. And then next you've got your auth layer. And there's a lot happening in the auth layer, not just authenticating, but also potentially authorizing data access, perhaps in a very fine-grained manner, but perhaps not. And your auth layer covers a lot of personas as well. It's your API consumers, yes, but a lot of different groups of engineers, admins, possibly even your business stakeholders that are involved in your API program. So that's playing an important role. After that, we've got what I call the protocol layer. And for this is all about sort of laying down the rules of engagement through things like having your API specs. But it can really, also provide attackers with some information about how your system works. But it's absolutely a layer that's there that prevents your systems from being wide open. And then we move on to the gateway itself. So this is the layer where we start actually processing API requests. And it's often thought as the layer where the API exists, right? But as we all know, the API is more than just the proxy. So we've got more layers than this that we have to think about. Next is monitoring. And I've added it at this point, although, obviously when done properly, you could argue that there's a few different monitoring layers. That's the beauty of this model, really. The layers are quite arbitrary, and it's really just an analogy to get the point across. So monitoring is in here, but it's really an example of a layer where technology on its own isn't sufficient. You can't just put in a monitoring layer. It really requires a large amount of planning, a lot of hard work to ensure that the right things are being monitored and that you've got the right alerts set up and that kind of stuff. So you really need to make sure this tool is a help rather than a hindrance. You've got to be able to see the wood for the trees, right? Next one is your CI/CD layer. As I was just listening to the previous speaker, another really critical technology. And notice that this one is the first one where it's not really anything to do with the request and response for the API. But as a defense, it's absolutely one of the most critical layers. This is really your opportunity to ensure that all of your security policies, your design guidelines, and all that stuff are properly implemented for every API. It's where you use automation to reduce human error and gain consistency. So really important layer. And then we have the API management platform itself. So when it comes to the API platform you're using, there's a bunch of tools here that form their own layer of security. So you have a suite of tools to allow you to configure and develop API security, right? So you have the tools to help you organize your APIs, you have your tools to help you publish your APIs. And but depending on the API platform you're using or the technique you're using, you might not even have this layer. You might be using a more sort of generic gateway product, and you could be missing out on a lot of the security that comes with these sorts of features. The ability to reuse policies and flows across all your APIs, for example. And the final layer is the service layer. And this is, the sort of integration piece, I suppose. And it could be any number of things. It could be a bit of a Wild West, and typically is. Your standard typical API platform is going to be connecting to a wide range of these things. Some old, some new, but it's definitely a security layer that needs to be thought about. You could argue actually that there's a slice or two of cheese for each one of these types of systems. But again, as an analogy, having a layer here, I think makes sense. So that's what we've got across technology, and we'll see in a sec how they work together. But let's quickly just look at these human layers and see what I mean by that. So the first one is your developer documentation. Probably heard quite a lot on this topic before. Again, I heard the previous speaker sort of talking about this too. It's everything you can do to educate the people who will be responsible for working on your API platform. And one thing that's very clear is that you do need excellent developer guidelines as a way to ensure your team use them in terms of their ability to learn and apply the guidelines. Although, yes, you also have policing of those guidelines potentially done in your technology layers. In theory, your CI/CD pipeline should be sort of implementing checks across everything that you have in your guidelines. It's even tempting to think that maybe this is the most important layer. Maybe this is the only layer you need. Let's just educate people and hope that they do the right thing. But can it prevent every security issue on its own? I don't think so. Next one is an operating model. So this is moving on to it's another human factor, but it's about the business making it possible for good API security to actually happen. It's about the business being really involved in the API lifecycle, having a proper team around it, as opposed to it being seen as a function that's looked after by the IT team. Having a strong operating model around APIs is really critical to ensure that your security best practices are actually always followed. It's all about governance. And you can start to see how some of these human layers are going to be really critical when it comes to preventing incidents from happening. And the next one is sort of a little bit more subtle, the mindset, but it makes a huge difference. Have you ever worked somewhere where APIs are used, but the business itself doesn't really understand, what they're for, or somewhere where the business isn't actually aware that the whole reason for being is kind of based on APIs, or maybe somewhere where security is about being reactive with a sort of fingers crossed attitude. If you've got that as your base layer, that's going to open up some holes. And the last layer, this is the bonus layer. Seeing as this is a community event and everything, I'm stretching the paradigm a little bit here. I thought I'd throw out a community layer. Really trying to highlight the great work that comes out of all these communities like AppSec, and I heard it being called apidays today. I've always said API days, but communities like these really put in the hard work getting the security message out there, and I think that that forms a pretty decent layer in itself. So this is what we've got in total. These are our layers, and excuse me while I have another quick drink. So this is where it gets good. Let's start thinking about putting the Swiss cheese model actually into practice. And what I haven't done here is actually try and draw any arrows through my cheese, basically because I'm not good enough at PowerPoint to do that. You might have noticed that I've broken out some parallelograms and a few sort of squash circles, but getting the arrows to go through those layers was too hard for me. So you'll have to use your imagination there. What I want to do is take another look through those OWASP 10 lists, the OWASP 10 API risks and have a think about what sort of exploits those risks relate to. And then from that, you should really be able to start seeing how the Swiss cheese model can really sort of help us understand a bit more about API security. So if we look at the list again, and let's take 3 sort of common exploits that we can all sort of understand and talk through how they might work with this model. You'll see that exploiting any of these risks can absolutely register an effect on more than one part of your system. And that's where looking at these things in layers really, really helps. If you think about it, a risk from the list doesn't actually correlate to any one specific part of the request or response. That's not a criticism in any way of the OWASP 10 list, far from it. I'm just sort of highlighting that exploits cross boundaries. So if you look at exploit number 1, for instance, an attacker trying to gain some unauthorized access to run some APIs, that maybe covers the API OWASP risk 1, 2, 3, 4, 5, maybe more of them. An enumeration attack, that's sort of described quite well in the API 1, a broken object level BOLA attack. But is it just that one? Or a SQL injection attack? Is that a security misconfiguration, which is API 8? Is that an unsafe consumption of APIs, API 10? It could be all of those, right? So we use this kind of simplified example so we can think about how the Swiss cheese model works and what it can show us about API security. And you see diagrams like this everywhere. We all draw them. They don't really do anything to highlight the layers of defense that can be built around APIs. And diagrams like this get used all the time. You don't actually ever see any Swiss cheese diagrams. So maybe between all of us, we can change that. I'll see what you think by the end of the presentation. Okay, so attack number 1. So in this scenario, let's think about which of our layers are actually playing a part. Gaining unauthorized access, the attacker may or may not have an account already, but this looks like an auth thing, right? So let's actually take a look. Let's step through this one layer at a time. So our attacker's trying a range of different auth-related attacks. And let's say the auth server's there, it's dealing with a lot of that, but let's look down through the layers and see what else is happening. So what layer, probably didn't really do anything. The request looks pretty normal. The auth layer, yeah, it's doing its job. It's detecting stuff. The protocol layer, this has already actually helped us. It's defined the sort of tightness of the auth requirements to actually even gain access to the system. The gateway layer, well, that's blocking the unauthorized access. So working with the auth layer, hopefully has done its job. The monitoring layer, that's also doing a job. It's detecting unusual parameters, unusual traffic patterns, unusual auth attempts. So all of those sort of technological things are working and doing their part. But then your CI/CD layer. Now that should, if deployed, properly, should really have prevented any code with any auth exploitable things from being deployed in the first place. Your API platform layer, that should have given you a load of tools to implement your chosen auth model. And your service layer, getting further down the stack, that should also hopefully be allowing you to make even deeper auth checks, when you're calling your apps or services in your service layer. And of course, your human levels, educating your developers on auth policy, making sure that, auth is best practices are in place across the business, that the business is fully across it, and even down to the good old API community, all of the education and innovation on this sort of topic all play their part. So you start to see how actually we had almost all of our layers working together there. And if you assume that attacker actually had an account and was looking to bypass the authorization, you can see how that kind of penetrates a lot deeper into the stack. Let's look at another one. So an enumeration attack. And for me, this is really the old classic. Does anyone else still do this on web pages? Occasionally you still find one where you can do it. There's an ID 1, 2, 3, 4, 5 in the URL, and it's just so tempting to just have a little fiddle with it. And of course, the good old hacker community do that en masse and automate it. So we can't really expect the WAF or even really the auth server to maybe do much to prevent this sort of in the first instance. Those layers aren't really going to do much. This user's got an account and they're just making regular requests after all. But then starting at the protocol layer, we start to be able to secure ourselves against this kind of exploit a little bit more. So this is where we can make sure that the spec makes it as hard as possible to sort of game the system. The gateway layer might be servicing these requests and returning negative results based on the dodgy IDs that are being plugged in, but it's logging away to your monitoring level. And the auth server may be playing a bit of a part. It might be denying authorization to access data that is trying to be accessed. But the monitoring layers, it's going to start to see a lot of bad requests with bad parameters that don't make sense. So they are all cumulatively doing their job. And it may be that these layers alone are going to defend against the exploit, but the other layers are doing their bit too. The CI/CD layer could have checks in place to ensure that you don't ship any code that uses numerical IDs. The API platform itself hopefully has got developer tools built into it to support this by providing alternatives, like UUIDs, whatever else you want to use. Maybe the service layer was doing its bit, sort of rejecting a southbound request that made its way through the gateway. And you can see that the human layers are coming in and helping here too. Okay, and the final one, and you're probably starting to see how this works now, SQL injection attack, another classic. And again, the requests look legit, but the gateway smells a rat. It filters out the SQL commands and probably blocks the request on the basis that you have been able to implement your API with basic checks and filters for this sort of stuff. So it's the gateway that alerts the monitoring layer, which alerts the business. But our other layers have played their parts too. You can see what happens here. The gateway layer filters out the SQL and the request. But your CI/CD layers hopefully prevented code with any sort of SQL vulnerability being deployed. Your API platform layers giving you some tools to sort of parse out SQL injection attacks. And then obviously in your human layers, you've hopefully educated your developers to be very, very careful when using dynamic SQL, and so on and so forth. Okay, so those are three examples, that I hope have highlighted how the Swiss cheese method really is useful as a way to think about API security. And one thing that really inspired this, I suppose, was seeing security implemented at the wrong layers, or maybe doing the wrong job at the wrong layer. Perhaps the network team's vision doesn't really line up with your API team's vision, or perhaps the management is telling everyone that they've got security fully under control. And you might recognize some of the sentiments in the diagram here, just read the documentation. We've given you a training budget. What's the problem? Just get it done quickly. All that sort of stuff. And this is the sort of stuff we can see happening. So looking back at our layers, we see a lot of this in some pretty major organizations that probably should know better, to be honest. This is the sort of stuff we see happening. So trying to detect everything at the WAF is really, really common. If the security team sort of own that piece of equipment or those platforms and are trying to take the lead on this, then quite often you'll find that they are trying to really detect and deal with everything at that layer. They're not thinking of the fact that inevitably some things are going to pass through. In the auth layer, we just see still, basic authentication, shared accounts, really sort of broad-based permissions, dodgy passwords, that kind of stuff. In the protocol layer, your API taxonomy just may not be tightly defined enough. There may be just some very generic sort of off-the-shelf APIs that are sort of easy to exploit. In your gateway layer, very common for your gateway to have been procured, configured for throughput, not necessarily configured for security. Your monitoring layer may have been a bit of an afterthought. It's focused on raising system warnings, but not really dealing with security events and really not being, I suppose, updated frequently enough and configured at that kind of fine-grained level. Your CI/CD layer, very common for that to be in place, but for it to really only offer warnings, some basic linting, but not actually enforcing anything. It's something that obviously needs a lot of work to be put into it to do right. In your API platform layer, again, there's there's a lot of capabilities typically in those platforms, but perhaps those capabilities are being applied, sparsely or inconsistently, or maybe a lot of those features just aren't being used at all. And down when it comes to the service layer, as I said, it could be a bit of a Wild West, and quite often there's just third-party services or just legacy services being executed, without question. Down in the human layers, quite often, obviously, we don't see solid developer guidelines, very inconsistent style, maybe some documentation being run by one team, a different style being used by another team. The operating model layer, we often see that there isn't really ever a genuine end-to-end view of the API program in a business. The business mindset might be that security is just really a technical sort of IT problem and not really a business problem. And then in that community layer, sometimes we see happening people sort of searching reactively rather than participating actively. So what should be happening? Now we know how to think in terms of the Swiss cheese model. Here's a few ideas about what should be happening with your API security. Thinking in terms of these layers, accepting that you can't detect every attack with one tool, allowing each layer to really, really do the job that it's meant to do, spending that time to unite your teams and instill that sort of security, that spirit of security at every single layer, really making use of all the tools that your platform or all the other tools that you have in your arsenal, and making sure that your engineers and the business have the time to focus on each layer. And this is what that could look like. At the network layer, your WAF, detecting unusual traffic patterns and alerting you, yes, but just doing that, doing what it's meant to do. The auth layer, using one of the modern frameworks that are available there with real-time control, very, very deep and granular control. In your protocol layer, making sure your API specs are very succinct. They give nothing else away. Really, really tight specs, really important. In your gateway, make sure it's configured to use the security tools that it provides. Same in your monitoring layer. You've got to have extensive coverage across every single layer, and it needs to be very proactive in its alerting. It needs to be updated continuously as you start to appreciate new attacks or exploits or issues that are occurring. In your CI/CD layer, making sure that you've got really extensive test automation against absolutely mandatory criteria. So it should become second nature for your developers to create APIs that will pass. But that layer needs to be there to ensure that everything goes through the same, that everything's been tested the same way, and that all of the criteria in your developer guidelines are actually referenced and tested for in your pipeline. At the API platform layer, this is a critical one where you can apply a security framework universally from the top down. If you put the time in to define your security sort of globally at the top level in your API platform and make sure that can be implemented across all your APIs, then that is something that should be done. In your service layer, making sure your services are executed with extreme caution. And then in the human layer, having your developer guidelines, making sure they're done well, make sure you've got governance across the whole API lifecycle and the business layer, instilling that security first mindset. And when it comes to community, active participation has got to be the thing. So that's all I've got. Thanks for listening. I hope that opened your eyes to a new way of thinking about API security, perhaps one that will help to sort of unite your business or your clients to come up with a more holistic way of doing API security. So thank you.
That was a great and very comprehensive way to wrap up the day. I appreciate that, Leon.